Welcome to our deep dive into the future of speech recognition. We're going to be looking at a paper by Ani Hanun. It's called The History of Speech Recognition to the Year 2030. And it's really interesting. So look at kind of where this technology is going and what it could mean for all of us.
Yeah, it's interesting. This paper goes beyond just sort of looking at trends. It actually lays out kind of a framework for predicting how technology might advance. And it's inspired by the work of Richard Hamming,
Oh, wow.
who is a brilliant mathematician who actually had a knack for, you know, pretty accurately forecasting the future of computing. um, and his strategies really emphasize like a deep understanding of fundamental principles
Yeah.
and a willingness to kind of challenge assumptions. And those are valuable, even beyond just the world of speech recognition.
Right. So before we even get into the predictions, let's sort of set the stage a little bit by looking back at the history of speech recognition, at least the recent history.
Yeah, so, the past decade has really seen a revolution in the field, largely driven by the advent of deep learning.
Hmm.
This shift from more traditional statistical methods like hidden Markov models to neural networks has just been a game changer. One very specific example is this going from using Mel-frequency substral coefficients as features to directly using the raw audio waveform as input to these models, which significantly improved the performance. And, the availability of massive data sets, the increasing power of GPUs, and also the development of more sophisticated learning algorithms have all contributed to this, like, really remarkable progress. And in fact, there's been work that shows automatic speech recognition systems have now surpassed human performance on certain benchmarks.
Wow. That's wild.
It's really amazing to see.
Yeah. It's incredible to think how far we've come in such a short period of time. But the paper argues that just focusing on reducing word error rates may not be the best way to measure progress going forward.
Yeah, that's right. So, while reducing word error rates has obviously been a primary focus, it's becoming increasingly clear that we need richer representations of speech to really capture those nuances of human language. Hannon actually suggests that the future lies in developing systems that can not only transcribe words accurately, but also understand the intended meaning, even in the presence of ambiguity or uncertainty.
I see. One of the concepts that the paper mentions is the use of lattices. Can you explain what those are and why they're so important?
Yeah, so imagine you have a traditional speech recognition system that outputs a single best guess transcript.
Right.
So this approach doesn't really account for that inherent ambiguity in spoken language.
Okay.
Lattices, on the other hand, provide a more nuanced representation by encoding multiple possible transcriptions, each with an associated probability.
Huh?
So it's kind of like having a map with multiple routes from point A to point B,
Yeah.
each with the likelihood of being the correct path. This allows downstream systems to actually leverage this uncertainty and make more informed decisions.
That's a great analogy. So instead of just getting a single string of words, we get this probabilistic map of possibilities,
Hmm.
which allows for a deeper understanding of what was said.
Precisely. And lattices and other richer representations like weighted finite state transducers allow us to move beyond simply word-level accuracy and toward a more sophisticated understanding of spoken language, including aspects like intent and speaker certainty. This shift is crucial for developing truly intelligent speech recognition systems.
This all sounds very promising, but the paper also highlights a pretty significant shift in where this processing will happen. It argues that on-device speech recognition will become the dominant paradigm in the coming years.
Yeah, that's right. There are several converging factors that are driving this shift. Concerns about privacy are paramount. People are increasingly wary of sending their voice data to the cloud. So on-device processing offers a more secure alternative, keeping that sensitive data localized. Additionally, the demand for low-latency applications like real-time translation or voice control in time-sensitive situations necessitates on-device processing to eliminate the delays that would be associated with cloud communication.
Right.
And finally, the desire for always-on functionality, even without internet access, further reinforces the need for on-device capabilities.
So it's a combination of privacy, speed, and accessibility that is pushing us toward this new paradigm. But on-device processing must pose significant challenges, right, in terms of computational resources and model complexity.
Absolutely. So moving speech recognition to resource-constrained devices requires us to really rethink model design and training. We need to develop models that are not only accurate, but also incredibly efficient in terms of their computation and memory usage. And this has actually led to a surge in research on model compression techniques.
Can you give some examples of these techniques and how they address the challenges of on-device processing?
Yeah, sure. So one promising approach is model quantization, which involves reducing the precision of the numerical values used to represent the model's parameters.
Okay.
So by using lower precision approximations, we can significantly reduce the model's size and computational demands without a significant drop in performance. Another technique that is gaining traction is knowledge distillation,
Hmm.
where a smaller student model is trained to mimic the behavior of a larger, more complex teacher model. This allows us to transfer knowledge from a computationally expensive model to a more efficient one suitable for on-device deployment. And then you also mentioned sparsity earlier, right?
Where a large percentage of the model's parameters are intentionally set to 0.
Exactly. Sparsity is a very interesting avenue for creating lighter weight models. It involves pruning connections based on their magnitude or using specialized training algorithms that encourage sparse solutions. The challenge, though, lies in determining which connections to prune without sacrificing accuracy. So this is an active area of research with immense potential for on-device speech recognition.
And what about training these models on devices? Traditional supervised learning requires such vast amounts of labeled data, which can be difficult to obtain on a personal device.
Right. So that's where the concept of weak supervision comes into play.
Okay.
It offers a way to leverage readily available signals like user interactions or corrections to provide feedback to the model during training.
I see.
Instead of relying solely on explicit labels, we can use those implicit cues from user behavior to guide the model's learning.
Okay.
And this is particularly relevant for on-device training where real-time user interactions and feedback are readily accessible.
So the model is constantly learning and adapting based on how users interact with it, essentially personalizing itself over time.
Precisely. Weak supervision allows us to overcome the limitations of traditional supervised learning and opens up exciting possibilities for personalized on-device training. And, this brings us to another key aspect of the paper's predictions, this increasing importance of personalized speech recognition.
Okay. Let's dive into that.
Yeah.
It sounds like a game changer, especially for users with unique needs or those who've been historically underrepresented in training data.
Absolutely. But before we get into the details of personalization, let's maybe take a moment to explore another significant trend that's shaping the future of speech recognition, the rise of self-supervised learning.
Okay, yeah. That sounds like a good place to start. Can you tell us more about self-supervised learning and why it's so important for the future of speech recognition?
So self-supervised learning is kind of a paradigm shift in how we train machine learning models. Instead of relying on explicitly labeled data, the model is tasked with predicting parts of the input data itself. So for example, in speech recognition, a model might be trained to predict the next frame of audio given the previous frames. And this process helps the model learn inherent patterns and representations within the data without relying on external labels.
So it's like the model is teaching itself by trying to solve puzzles within the data itself. Why is this approach so valuable for speech recognition?
Well, it's crucial because, labeling data can be incredibly expensive and time-consuming.
Right.
And it also allows us to leverage the vast amounts of unlabeled speech data that's available, making it much easier to train more powerful and adaptable models.
That makes sense. But are there any challenges associated with this approach?
Certainly. One of the main challenges is the sheer scale of computation required. Training these models on massive data sets can be incredibly resource intensive. Another challenge is the need for, again, lighter weight models that can be trained efficiently on less data. If we want to make self-supervised learning more widely accessible, we need to develop models that are less computationally demanding.
So while self-supervised learning holds immense promise, there's still some hurdles to overcome. Are there any research directions you find particularly promising in addressing these challenges?
Yeah, there are a bunch of interesting directions researchers are looking at. So they are investigating various approaches, such as incorporating sparsity into self-supervised models, as we discussed earlier, or developing new optimization techniques to speed up training. There's also a lot of work being done on exploring ways to incorporate prior knowledge into models to improve their sample efficiency.
It seems like there's a lot of exciting work happening in this area. But before we get too deep into the technical details, let's bring it back to the user. You mentioned that the paper predicts a move towards personalized speech recognition. Can you elaborate on what that means and why it's such a significant trend?
Yeah, of course. Personalized speech recognition is all about tailoring speech recognition systems to the unique characteristics of individual users, taking into account their voice, their accent, vocabulary, and even their social context. So imagine a world where your speech recognition software understands you as well as your closest friend.
It sounds like the ultimate goal is to create a speech recognition system that feels like an extension of yourself,
Yeah.
seamlessly understanding your every word and intent.
Precisely. And this level of personalization has the potential to revolutionize accessibility for people with speech disorders or those who speak languages or dialects that are underrepresented in current training data sets. It could also significantly enhance the user experience for everyone by making interactions with technology more intuitive and natural.
This level of personalization sounds amazing, but it must also come with its own set of challenges. What are some of the key research areas that need to be addressed to make this vision a reality?
That's a great question and one that researchers are actively grappling with. We'll dive into those challenges and explore the cutting-edge research that's paving the way for personalized speech recognition in our next segment.
We were just talking about the really exciting potential of personalized speech recognition,
Mm-hmm.
and it really does seem like a game changer, especially for those who have been underserved by current technology. But what are the hurdles that researchers are going to need to clear to make this vision a reality?
Well, one of the biggest challenges is developing robust and efficient methods for on-device training and adaptation. Remember, we want these personalized models to live on the user's device, learning and evolving kind of in real time as they interact with the user.
So it's not just about building a personalized model. It's about creating a system that can continuously learn and adapt to the user's evolving speech patterns and preferences. That sounds incredibly complex.
It is. Traditional methods of model training, which often rely on those large centralized data sets, they're not really well suited for this task. We need new approaches that can leverage the limited data and the computational resources available on personal devices, all while still preserving user privacy.
Right, and privacy is a huge concern when we're talking about such personal data as an individual's voice and speech patterns.
Yeah.
So how are researchers addressing those concerns?
Yeah, that's a crucial consideration. Federated learning is one promising avenue.
Okay.
It allows models to be trained collaboratively across multiple devices without directly sharing raw data.
Okay.
So essentially, each device trains a local model on its own data, and then only the model updates, not the data itself, are shared and aggregated to create a global model. So this approach ensures that sensitive user data remains on the device, while still enabling collaborative learning.
So it's like having a team of researchers working together to develop a better model. But each researcher only has access to their own data, and they only share their findings, not the raw data itself.
That's a great analogy. Another important area of research is differential privacy, which involves adding carefully calibrated noise to the data or model updates to protect individual privacy. And this ensures that it's impossible to infer sensitive information about any individual user from the shared data or model parameters.
It sounds like a lot of clever techniques are being developed to safeguard privacy, while still enabling personalized model training. But even with these advances, training these personalized models on device must require a lot of computational power and energy. How are researchers addressing those constraints?
Yeah, you're right. Efficiency is paramount when you're dealing with these resource-constrained devices.
Hmm.
That's why there's a huge push to develop lightweight models and training algorithms that minimize computational overhead and energy consumption. And we've already touched upon techniques like model quantization, knowledge distillation, and sparsity. All of these aim to reduce the model size and complexity without sacrificing accuracy.
Yeah, it's impressive how much innovation is happening in this area. It seems like researchers are really pushing the boundaries of what's possible with on-device machine learning. But let's shift gears for a moment and talk about the broader impact of personalized speech recognition. What are some of the potential benefits beyond just improving accuracy and efficiency?
Personalized speech recognition has the potential to be truly transformative, especially for individuals with disabilities or those who speak languages or dialects that are underrepresented in current data sets. So imagine a world where people with speech impairments can communicate effortlessly using technology that understands their unique speech patterns.
Yeah, that would be incredible. It would empower so many people who have traditionally been excluded from the benefits of speech recognition technology.
Exactly. And it goes beyond just accessibility. Personalized speech recognition could also lead to more engaging and personalized user experiences for everyone. Imagine voice assistants that understand your preferences, anticipate your needs, and adapt to your communication style.
So it sounds like a truly personalized digital companion that can seamlessly integrate into your life. But as with any powerful technology, there are also potential risks and ethical considerations that we need to be mindful of.
Absolutely. As personalized speech recognition becomes more prevalent, we need to carefully consider its implications for privacy, fairness, and bias. For example, if these systems are trained on data that reflects existing societal biases, they could perpetuate or even amplify those biases.
That's a crucial point. It highlights the need for responsible development and deployment of this technology. We need to ensure that these systems are designed and trained in a way that promotes fairness and inclusivity. But let's not get bogged down in the potential pitfalls just yet. The paper also highlights some incredibly exciting possibilities for the future of speech recognition applications. Can you give us a glimpse of what we might expect to see in the coming years?
Yeah, so Hannon predicts that by 2030, speech recognition will be seamlessly integrated into nearly every aspect of our digital lives. We'll see a dramatic increase in the automation of tasks that currently require human intervention, like transcription, translation, and customer service.
So it sounds like we can expect significant improvements in the capabilities of existing applications like voice assistants and dictation software. But what about truly transformative applications that go beyond just automating existing tasks?
Yeah, that's where things get really interesting. Hannon argues that the real breakthroughs will come from tackling those AI-complete problems, like natural conversation and broader question answering. These are challenges that require a deep understanding of language, context, and human reasoning. They're kind of the holy grail of artificial intelligence, and speech recognition is a key enabler.
So while we can expect to see incremental improvements in existing applications, the truly mind-blowing advancements might still be a few years away. But the progress that we've seen in recent years, particularly in areas like deep learning and self-supervised learning, gives us good reason to be optimistic.
I agree. And it's not just about the technology itself, it's about how we as a society choose to use it. Speech recognition has the potential to connect people, break down barriers, and empower individuals in ways we can only begin to imagine.
That's a powerful thought, and it underscores the importance of not just focusing on the technical advancements, but also on the ethical and societal implications of this technology. As speech recognition becomes increasingly integrated into our lives, we need to have open and honest conversations about its potential benefits and risks, and ensure that it's used in a way that benefits all of humanity. But before we get too philosophical, let's bring it back to the paper. We've covered a lot of ground, but there's one more key prediction that we haven't touched on yet: the evolution of how we measure progress in speech recognition.
You're right. Hannon argues that relying solely on word error rate, while useful in the past, is no longer sufficient to capture the true capabilities of modern speech recognition systems. As these systems become more sophisticated, we need more nuanced metrics that take into account factors like intent, context, and the ability to handle complex language structures.
So it's not just about transcribing words correctly. It's about understanding the meaning behind those words
Right.
and the speaker's intention.
Precisely. This shift towards richer evaluation metrics is crucial for driving progress in areas like natural language understanding and dialogue systems, which are essential for building truly intelligent and interactive speech recognition applications. And with that, let's move on to our final part, where we'll synthesize what we've learned and explore some potential future implications.
We've spent this deep dive exploring Ani Hannon's predictions for the future of speech recognition. And it's clear that this technology is poised to become even more powerful and even more integrated into our lives. So as we move towards this future, what are some of the key takeaways that we should kind of keep in mind?
Well, I think that the shift toward on-device processing is really paramount, and it's driven by privacy concerns, this demand for low latency, and the desire for that always-on functionality. And this trend is really going to necessitate the development of those lightweight, efficient models capable of running on resource-constrained devices. So this is where techniques like model quantization, knowledge distillation, and sparsity really come into play.
And it's not just about shrinking those models, right? It's also about developing those new training paradigms, like federated learning and weak supervision, that allow us to personalize these models on device
Yeah.
while still preserving user privacy.
Absolutely. The future of speech recognition is really deeply intertwined with personalization. Imagine a world where speech recognition systems are tailored to individual users, accounting for their unique voice, their accent, vocabulary, and even their social context. And this has the potential to revolutionize accessibility for individuals with speech disorders and those who speak languages or dialects that are underrepresented in current data sets.
Yeah, this level of personalization could also lead to more intuitive and engaging user experiences for everyone, with voice assistants that truly understand our preferences and adapt to our communication style.
Yeah, definitely. But it's also crucial to acknowledge the potential ethical implications of this technology. As personalized speech recognition becomes more prevalent, we need to be vigilant about issues of privacy, fairness, and bias. We need to ensure that these systems are designed and trained in a way that benefits all of humanity.
Yeah, it seems like a balancing act, right? Between harnessing the power of this technology while also safeguarding against its potential pitfalls. The paper also highlights the need to move beyond those simple word error rates as a measure of progress.
Right, relying solely on word error rate, while it's been useful in the past, it's no longer sufficient to capture the true capabilities of these modern speech recognition systems. As these systems become more sophisticated, we need more nuanced metrics that take into account things like intent, context, and the ability to handle those complex language structures.
So it's not just about transcribing words correctly, it's about understanding the meaning behind those words
Yeah,
and the speaker's intention.
exactly. And this shift toward those richer evaluation metrics is crucial for driving progress in areas like natural language understanding and dialogue systems, which are essential for building truly intelligent and interactive speech recognition applications.
So the paper paints a picture of a future where speech recognition is seamlessly integrated into nearly every aspect of our digital lives. And we'll see that increased automation of tasks like transcription, translation, and customer service. And the emergence of those transformative applications that tackle those AI-complete problems like natural conversation
Right.
and broader question answering. It's clear that the future of speech recognition is just brimming with possibilities. But as with any powerful technology, it's our responsibility to guide its development and ensure that it's used ethically and responsibly. Hannon's paper provides a really valuable roadmap, highlighting both the exciting potential and the challenges that we need to address. It encourages us to think critically about the future that we're creating and to actively shape it in a way that benefits all of humanity.
Yeah, it's been a really fascinating discussion. This deep dive has been an exploration of not just the technical advancements in speech recognition, but also the broader societal and ethical considerations that will shape its impact on our lives. And as this technology continues to evolve, it's just crucial to stay informed, stay engaged, and be prepared to navigate this exciting and complex landscape that lies ahead.
Well said. Thank you for joining us on this journey into the future of speech recognition. And to our listeners, we leave you with this final thought to ponder. In a world where machines can understand our every word, what will it mean to truly listen, to connect, and to communicate?